Okay, these are going to be the answers to the questions here for the tensile testing um, notes questions part 2, which is Tuesday, April 21st. So the first question is review over the stress strain curve in the notes, and what does the linear or the straight part of the graph represent? Check all that apply for this one. So for this one here, here's the straight part of the graph, okay, where the stress and the strain are in a constant ratio to each other. So this part here represents what's called the elastic range. Okay, up in this section here, if you're putting a force on a material and you release that force, the material will go back to its original shape. Very similar to if you think about just putting a little bit of a force on a rubber band, you stretch it, and then you release the force and the rubber band just goes back to its original shape. It's also called the proportional limit area too. So for this one here, you had the elastic range and the area where the stress and the strain are proportional to each other. Question number 2, what is the stress at which proportionality ceases to exist? What is that called? We call that, well, it has a number of different names. And it says in the question to go through the materials and find the different areas. Well, it's the proportional limit, this part right here, okay, where this proportional region stops and it begins to curve instead of being on a straight line. Okay, that area there is also called the elastic limit right here at the end of that straight line. Okay, and it's also called the yield point, is a little bit past this, just a tiny bit past your elastic limit. Okay, your yield point is when you're actually just past the elastic range, where it's going to start going into the curved range where it's going to start deforming. Instead of, if you release the force on it, it would go back to its original shape. So you had two answers for that one. Question number 3. Let's see, the proportional or linear, the straight line part of the graph, can be used to calculate Young's modulus of elasticity. The formula for using or calculating Young's modulus of elasticity is the stress divided by the strain. Letter B. Question number 4, what is the term used to describe a material's ability to resist stretching when loaded with a force? Ability to resist stretching. So we've got some terms here. You might think toughness and stiffness would be the same thing, but they represent different things. Stiffness is the term that we look for when we're talking about our ability to resist stretching when you put a force on it. Question 5, what is the region of the graph called where the load is, if the load is removed, the material will return to its original length? That is what we call the elastic region of the graph. And again, we're going back to this part of the graph. This part of the graph right here, the straight line, and it's shown in all of these different pictures. All of these straight line areas are called the elastic region of the graph. Okay, and here was our equation for calculating Young's modulus, which was the previous question, the stress divided by the strain. Keep moving on. Let's see. Question number 6, what is the term used to describe the uppermost part of the point of stress of the elastic behavior of the stress strain graph? That is what we call the elastic limit. Okay, the elastic limit. So this point right at the end of the straight line right here, anything below this is the elastic range of the graph. Okay, so the end of that blue line right there is what's called the elastic limit. There it is right there. Okay, and if you keep adding force after that point, the material is going to get deformed and it goes into this region here. Okay. Number 7. What does the area under the proportional part of the graph represent? It also represents the amount of energy a material can absorb and still bounce back when the force is released. We call that area resilience. Okay, that's a characteristic. Okay, so if we're looking at the graph, this area here, okay, this area right here under the graph, this would be resilience. So again, if you any point up to this, if you're putting the force on a material, okay, the material is stretching, but if you release the force, it'll bounce back to its original shape. Remember here, this is representing the amount of force that you're putting on the material. So as it goes up, it's getting more force, and as it's going over, the material is stretching. So you can think about this blue line. If you're putting force on it, it's stretching, stretching, stretching. But if you release that force, it'll bounce back to its original length. Okay. Question number 8. What is the point of the graph where the elastic region of the graph is exceeded? Okay. So that's this right here. You're putting force onto the material, but then if you put a little bit more force on it, you get to this point right here, and it's called the yield point. Okay, and at the yield point, that's where you're starting to now deform the material permanently. Yield point. Number 9, when you get past the elastic region, or the straight part of the graph again, of the stress strain graph, and keep adding stress to the material, it enters the region where if stress is released, the material will not rebound back to its original shape. So what do we call that region? What do we call this region here? Okay, you get past this point where the straight line stops. You continue to add more force going up, but now as you're going over, the line starts to curve. That's called a plastic deformation region. Okay, and again, what happens there is you're adding more force, and the material has now stretched to the point where if you release the amount of force that you're putting on it, it's not going to bounce back to its original shape. It's going to deform. It's going to be deformed permanently. Okay, number 10. What is the point of the stress strain graph that represents the highest stress the material can withstand, or the point that the material begins to neck, or that means is that it begins to thin out? Okay, and this is the idea right here, this picture on the right hand side, where the material, it's getting pulled from the top and the bottom, okay, and it begins to get thin. That's called necking. And this is the term that we're used for that. It's called the ultimate tensile strength. Okay, at this point, the material begins to get thin, and you know what's going to happen next. It's going to end up breaking if you keep putting force on it. Number 11, what is the term we use to describe the ability of a material to stretch into a wire? That's called ductility. Okay. Number 12, what is the point of the stress strain graph used to describe the point that the material breaks? Okay. We call that failure. And on the graph, that's illustrated right here, where the graph basically, the stress strain graph ends because this thing, if we were putting stress on this dog bone, the bone would be broken. It'd look like this. Okay, so that's the failure point. Number 13, what kind of material can withstand a large amount of stress and does not stretch very much before it breaks? That is a brittle material. So a graph that would be a brittle material would look like this right here. Okay, it takes a lot of force. The force is a high number, but you'll notice left and right, or the horizontal, it doesn't stretch very far and it breaks. Okay, that's a brittle material. And let's see, number 14, stress strain graph that has a very large area under the curve of the graph. Okay, when we look at a graph that looks like this right here, you have a large area underneath this graph. That represents a material, or like this one here is a better one even still. This is the material that's very tough. Okay, it takes a lot of force. Okay, it can withstand a lot of force, but you'll notice that it stretches very far as well. So that's a very tough material. Okay, and then 15 and 16 are just matching some of these questions here. Number 2, the point of the graph when the elastic region of the graph is exceeded, that is the yield point. Number 2, uppermost point of the stress of elastic behavior of the stress strain graph, that is the elastic limit point. Number 3, the point where the stress strain graph that shows where the material breaks, we call that the failure point. And number 4, what is the point of the stress strain graph showing the highest amount of stress that the material can stand before it starts to neck, and that's the ultimate tensile strength. Question 16, number 1, a material that will not stretch very far with a large amount of force applied to it, that's a brittle material. Number 2, material that can resist stretching when loaded with a force. That is very stiff. Number 3, a material that can withstand a large stress and has a large area underneath the stress strain curve. We call that tough. And ability of an elastic material to absorb energy is resiliency. So those are your answers to this part 2 of your tensile testing questions from April 21.